Good morning, everyone. This is Bruno from FAMIC Technologies Automation Studio. I'd like to thank you all for attending the fourth webinar of our series on Automation Studio 8.0, What's New? So this is the list of webinars that we're covering for today. So this is previous webinars. If you've registered to those, you'll have access to the videos. So normally you get access to those automatically after the webinar is completed if you've registered. They will be available on our website in due time. And the webinar that we'll be covering today is what's new for the electrical developments. This is a quick overview of the agenda that we'll be covering today. So we'll be going through various topics related to enhancements made on the Electrotechnical module of Automation Studio. I won't be covering too much on this right now. We'll go right into the presentation to cover those topics one by one. We will be reserving a questions and answers period at the end of the webinar. So if you have questions, please feel free to enter them using the questions dialog box. So inside your application here, you should be seeing the questions list. You can go and fill out your questions directly here. So again, thank you so much. I hope you guys enjoyed the webinar for today. And without further ado, I'll pass things over to my colleague, Shane.
Thank you, Bruno. So today I'm going to start with looking at the connector configurator. So this is a new configurator for the electrical connections that we have in 8.0. So I'm just going to start by looking at the builder that we have. So we have a new version, we've added new features to the connector builder here, which is available in the Electrotechnical tab. So just by clicking on the connector builder. In this project here, I've already added two connectors. So if you click on one of the pre-existing connectors here, you see we have the identification tab here, which shows basic information, part number, item identifier, general information like that. You also have a 2D builder. So the 2D builder you can use in the case that you don't have 3D information from the manufacturer for the shape and the form of the connection of the connector. You can actually create your own 2D version of it. Here we have a 3D builder. So we do have an IGS file here that we have integrated. So we've imported into the 3D connector builder, and we have positioned the various different elements in relation to that 3D file. So you can see here on the left we have the connector. The connector has a housing. It has a slot. Within that slot we have a mechanical reference point, and then we have 3 cavities. Each of these cavities then has a name, a number, and a connection point. So we can see here on the diagram here, we can see the connection. We have on a toolbar here, then it allows us to hide and show various elements. So if we look at, for example, first one here, we can display the cavity name. So if we just go here to the other side where the cavities are, so we can turn those on and off to different names. We can turn on and off a number for each one. We can show the connection points that's around on the other side again. So we can show the connection points here, and we can show the mechanical connection. So that's over here on the other side. So the mechanical connection is useful for ensuring the compatibility between the two, so the male and the female in this case. We have here different buttons that can display different 2D views or isometric views of the connector. So we can show an isometric here. Next over here we have the preview. So this allows us to see the male and female connectors. So we have here a male and a female connector. We can see how they look and whether they're properly connected. So we can move them apart here by using this slider, and we can see that they fit together correctly. We can also use different views here, so we can have a transparent view or an opaque view for the 2 different connectors, so we can see that everything fits together okay. So with this connector, once you have a connector configured, you can use this in a catalog, and then in the future you don't have to reconfigure it again. So you can just configure the catalog, configure the connector, save it to a catalog, and then just drag and drop it or add it to your projects, your other projects. So with that, the addition of the 3D connector, we have also added the different components that work with those connectors. So these are in the Electrotechnical Library, lines and connectors and connectors. And we have, first we look at the different symbols here. So for the different sockets or pins, so we have 3 of each. So if we just grab one out here first, we can zoom in. I'll just close that out of it. I'll just put them all on so we can just see them first. So we have 3 different pins of 3 different sizes. So these can be used whichever one, whichever size you want to use in your schematic. You can use any of them. They're all essentially compatible with one another. With any of these, what you can do is you can then assign it to a connector. So if I click on the connector here, you can see this one is compatible with the XD3. So I can select that, and then within it, I can assign it to one of the pins or one of the sockets, depending on which type that you've used. So in this case, it's going to be one of the sockets, and we can assign it there. Once you've done that, then you can see the name of that socket is assigned to it. If I create a copy of this, so I'll hold Control and drag this over here, it'll automatically assign it to the next available one there. We have the same here for the pins. So we have 3 different size pins. We can do the same thing with these. So I can use the different size one here just to show. And it's the same. You can add connection to one of the pins in there. So that's the sockets and the pins. We've also added in a connector picture. So this allows you to add in a picture, so a view of the 3D image. So it's one of the 2D or 3D images of the 3D connector. So here we can select one of the connectors. We can choose different views to show. So we can just select those there and close that. And you can see it's added those onto the schematic. You can then move these around how you like, and you can resize them as necessary. So you can just resize these, line them up on the page there. And the table here shows the connections, so between the different cavities, slots, and so on, and the different part numbers. We have all the information there. The next component then is the connector. So with the other ones here, it's individual pins within the connector. This component here allows you to configure the whole thing, so the entire connector in one single component. So I can select all of the different pins and add those, and that's added to my connector here. So you can see the three pins, and we can see the mechanical connection there. And I can do the same then for the XD3. So we can add this. And then what I can do is I can actually connect these together. So I just need to flip this one and then just plug them together. So if I just do a transformation here, vertical flip and connect. And then I can just create a little circuit here just to test. So with a little source and a lamp, you can just connect these up. So then if I run the simulation, you can see we have the power flowing through. So what we can then do with this, so we can actually disconnect it. So if I click on the disconnect tool, I can disconnect, and you can see the lamp goes out. You can then either reconnect it by clicking on it again, or by clicking on the reconnect tool up there. So we can also add a report. So I'm just going to go new spreadsheet report, and we have the connector list, which is here. So we can just add in a connector list project, which contains a list of all the connectors. It shows the different information on the connector. So you can see the part number for the housing, cavity numbers. Each of the cavities is there, the name of the cavity. We can also see so the part number of the pin and the socket. We have wire colors is there. We haven't configured those, and any different part numbers and so on that are in there. And you can also, as with all of the reports, you can hold control and click to follow the link, and that will show you where that component is on the schematic. So then just to show you where you can go with this, so we have here a diagram completed with lots of different connectors. So we have CAN bus devices here, and we can see we have different 3D connectors various places on the schematic with the tables and so on. Everything is connected up. You can also use the new diagnostic tool. So here, for example, we have our entire schematic created. We want to be able to check if the various pins and sockets and cables and wires and everything are all compatible. So we can go to the Electrotechnical diagnostic tools. We can run the diagnostic. We can see these new diagnostics that are available. So we can check the compatibility between the wire core, the gauge of the wire basically, and the size of the pins or sockets, and the compatibility between the insulation and the socket or cavity sizes. So if we run the diagnostic, we see here we get a warning saying that the terminal has ET34. The wire ET34 has a gauge of 4 millimeters squared, which is bigger than what is allowed. So we just stretch this out a little bit, or you can see it in the tooltip. We can see that the range is supposed to be between 0 and 1 millimeter, and that's bigger than what it's supposed to be. So we can click on the message in the message explorer, and it will zoom and highlight the component so we can see which one is causing the problem. So then we could obviously go in and fix that later. So now we're going to look at the different types of wires that are available. So some changes that we've made in 8.0 for the wires. So we have here, this is what we had in previous versions. So this was the standard wire type that we had up till 8.0. So you just see the black wire. We now have added in the options to show highlighting on the wires. So this is one example where you have a wire showing the internal part of it and the insulation on the outside. So we call this cut wires. You can also have it highlighted just to show the insulation on the outside of the wires. And these options are available from the View tab. So if we go to View here, we can choose the different options in the drop down. So 3 different options that we showed are available from this menu here. We also have new options for the colors of wires in simulation. So up till now, we had, this was the options that were by default in 7.0 up to 8, whereby when you ran your simulation, the wire would be colored based on the type of current that it was using. So if it was AC, it would be green, DC would be blue, and then if there was no voltage through it, then it would be gray. So what we've added is options to now change that color in simulation. So the first option that we've added is to have no highlighting. So if we run the simulation here, you can see that now in simulation, the wires are gray. So even if I change the voltage, there's a voltage change across here. There's no change in the colors of the wires. If we look at the previous way of doing it, so this is still true. So we still have the AC voltage in green and the DC in blue. So in this case here, this is the highlighting that we have decided to use. So you can see if we close the button here, this line becomes powered and it changes to green. Similarly over here for the DC, changes to blue. You can also use voltage as a parameter. So in this case, we have a scale. So depending on the voltage, the color will change. So here we have our system here. We have our voltage we're going to apply using this slider here. And currently it has 0 volts across that resistor, so 0 volts in the wire. And as we increase the voltage here using the slider, you can see that the color of the wire changes. So here we've just defined this for 4 different values and no value at the top. But you can add, if you see the plus here, you can add as many thresholds as you need. By default here, it's set up to have just 4. You can also do the same thing, but for current. So here we have this set up for current. And there's also, with the current option, you have the option to show if a wire is perfect. So in the case of a perfect wire, there is no voltage drop through it. So if we just click here, you can see this one has been set to be a perfect wire. So this will be highlighted in simulation in blue. So we can see that it's perfect wire. We have here then orange for no current. And again, here we can increase the current this time. And we can see the colors change as the current increases. So that gives you an indication of how much current is going through the wire, even before you come and insert a measuring instrument. Another option that may be useful is if you're doing a training scenario where you don't want to give too much information away in the simulation, so you want somebody to come and use measuring instruments and so on to evaluate what's happening in the circuit. You can have the wires to use their appearance, so their edit appearance, so the appearance that they have now, so we're not in simulation, we can edit the document. So in this case, this wire is blue, this one is green and black, the other one is black there, so we can have it such that the wires in simulation retain their colors, so they don't change based on the state of the circuit. So this can be useful in training scenarios or teaching sometimes where you want to just evaluate, use other tools to evaluate what's happening in the circuit rather than having the colors indicate that to you. You can also change individually for different elements. So here up till now we're using the global criterion, so that would apply to all wires. But you can for each category of wire. So we'll see in a minute what the different categories are. But for each category of wire, you can change which way it behaves. So whether in some cases you have no colors, voltage, or addition, or current, or whatever. The different options can be applied separately for each of the categories of component. So if we just look at where those properties are set. So So these options are set here. If we go to the simulation tab, we have here the global criterion, which is on this document, this standard here is set to current, but you can choose from the different ones there. And if you scroll down here, then you can see where you can configure each one. So the different voltages or the different currents have different colors. And if you change it to local criterion, then here you can change for each of the different types of component which criterion it will use. So next we're going to look at the different types of components that we have. So that this applies also to the wires, but we'll look at it for both of them here together. So we added component types for these components. So any component, if you go to its properties, you can see you can add in, you have a new property here, which is component type. So this allows you to define what type of component this is. And that list that we, from that drop down there is available here from the Electrotechnical standards. So if we go here, we see we have component types that are available here. So this list is all the different component types that have been defined in this project. Certain number of these are defined by default, but you can always create your own. For each type of, for each one of these types, you can define that as being either a control type or a power type. So for this, so for each type of component, so the advantage of using these component categories is that you can define different properties for each one. So here, if we go to the electrotechnical standards again, you can see for each component type, you can define different things. So here, for example, the PLC terminal has an IEC code of KFT, name a code TB, and then independently for each type, you can define what type of appearance it will be and what naming rules that will be associated with it. You can also set a default type. So when you create a new component, or if a component doesn't already have a type, then this is the type that it will be assigned. When it comes to default, here the default refers to whether it's a power or command type. So if you have your PLC terminal is set to default, if it's a command, obviously, then it will use the appearance for command. Otherwise, you can set different appearances for that as you wish. This also then, so you can see here we have the drop down that appears in each of the components. So in the component properties here, we have this drop down that's available. In each of the types, you can define the appearance as we see here. So the component appearance can be defined separately, or it can be the default, as I said. So the default then will go to either control or power. And these control or power are defined also in the project standards. So you define an appearance here for power, for example, with certain colors and line thicknesses and so on. So again, you can define different appearances here that you can select from here. So this my component appearance appears down here as an option in the list. The naming rules then similarly, each component can have the default naming rule, which will be something like the IEC standard, but you can define your own naming rules. So for each component type, you can have a different type of naming rule. Again, these are defined in the project properties, so similarly to where the Electrotechnical was defined. In the same way then for the wires, we can have different categories of wire. So if we just look here, we have a lot of similar stuff here. First, we have different types of wire that you can draw. So when you draw a wire, you can draw it as a straight line. We have a new curved wire that's available. So from this home menu here, you can see you can draw curved wires, and you can define also, so if you draw a line, a wire, you can define it as being direct. So here you have the option here for direct wire. So these are the different options of wire. A new option as well, a new thing that's available in this version is you'll see here when I click on a wire, we have this drop down that appears, which allows you to automatically select or more easily select what type of wire it is. So this is similar to the categories that we just saw for the component. You can select the different categories for the wire from there. This is an option, by the way, so I think it's off by default, but you need to go to the Automation Studio options here to turn on the option to show the context. So this option here, show contextual toolbar on lines, will show this drop down when you click on a line. So again, these have different categories that you can choose from, similar to the components. And each of these you can define an appearance, naming rule, a different naming rule for when that wire is part of a cable, and different numbering rules and so on. So there's lots of different options that you can use there. This is just showing here that you can, as we just did, you can right click on the wire to select it, or within the component properties, you can do the same thing. So you can make the same selection. And again, these wire types are defined similarly to the component types in the project properties. And we have the same options here. So the appearance, again, you can choose default. So it will be whether it's control or power wire, or the different appearance types that are also defined in the project standards. And for the default, for the naming rules, then it's going to use, normally it's going to be the IEC or name and naming rules, or you can create your own naming rules again for those components, for those wires. So the next thing that we're going to look at here is the simulation of the 4-quadrant machine. So these are the new simulation options that are available in this version. So what that means is we can now simulate different situations where the motor is being driven. So in this case, it's being, let's just run the simulation here. We can see in one case, we can have the motor running in different operation modes. So in this case, the motor is driving, so the torque is positive, speed is positive in Q1. In Q3 here, we can have it, the motor is driving negative, and which as a result, the speed is negative. Or we can have it reverse in regenerating. So here we have the, the motor is being driven and it's creating, uh, it's generating energy, or in the opposite direction here, we can have negative torque, positive speed, still in regeneration mode. What we've also added as well for these machines, so we have it just shown up here. You can see here the options to show where the torque is coming from. So because some of these components have a shaft or some of them have different variables, it's not always immediately obvious that what's driving what or which quadrant the device is operating in. So if we look here in these icons here that we have next to the machine here, we can see here the icon for a shaft is lit up, so we can tell that the power is being transferred through a shaft. And we can also see which quadrant we're operating in. So we have negative torque and negative speed. So in some cases, we have components that are being driven by variables, where then you would see the variable or the other elements would be highlighted. So you could have a curve, slider, or variable as the source of your torque. Some other new components that we've added. So we've added here new components, which are some DC machines. So we'll just have a look at those. So these are the new components. Let's just zoom the page. So we've added a few DC motors. So different types of DC motors, series wound, separately excited, shunt wound, or permanent magnet. DC generators, so the same types of categories are available for those. And DC machines, again, the same categories for each of those. We've also added different types for each. So in some cases, for example, this one here, we have the two ports, the M1 and M2 port. These ports indicate that you can connect a shaft to it. So like we saw in the previous diagram, you can plug a shaft here and connect to an external torque source or a torque load. So in this case, the torque and inertia are taken from the load through the mechanical connector. For these ones here, without the mechanical connectors, you can either apply a load torque by curve, by slider, or you can take torque and inertia through variables. We've also added here a three-phase induction motor. So this was something that was missing previously, and a three-phase transformer. So this is also a new component that's available here. Lastly, on this page is the different types of power bar. So if we just go to here to the electrotechnical lines and connections. In junctions. Then we have all of these components that are here. So the first one, power bar, 5 holes, 6 holes, and 7 holes. What these are is it basically it's a convenient way to connect multiple components together. So these are all internally connected. So we connect components between them. They're automatically connected. And these new ones here at the bottom as well, the power bar, these two have the feature that you can actually change the size. So here, this one is 5 ports by default. I can right click on this, I can unlock the size, and then if I extend it, it automatically adds in the extra ports to fit in the new size. So this one is very convenient if you're building something like a breadboard or something like that, that you can just easily add in any extra ports that you need. The next new components are the op amps. So we've added in a few different types of op amp. So we just have them all here. And these are available in the library as well. These are in control. Sorry, not in control. Sorry, these are in the basic, passive, and active components, and we have the whole section of operational amplifiers there. So these they are here. So these work as expected. We have them pre-configured in certain configurations. So for example, if we look at the op-amp feedback op-amp non-inverting, we have this configuration here with different resistance values that you can set. The output in this case is going to be 1 plus R2 or over R1 times V in. So if we look at the values here, we have two R's, the resistances have the same value, so we're going to get V out is twice V in. And if we run the simulation on this and we look at the associated plotter, so we just grab the plotter here. We can stop the simulation there. We've just ran it a little bit. And we can zoom in and we can see, let's just scale a little bit so we can see a bit better what's happening here. So you can see the output here is twice the input, which is what we would expect. And the next one we can look at just to show is the feedback differential op-amp. So this one is a slightly more complex equation here associated with it. We don't need to run again, so we just grab the plotter since it was already running the last time. So we just grab the right plotter for this. And we can look at the same situation here. So if we look at just where the cursor I previously placed on this is, you can see the equation here in this case with the various resistance values. It gives you the minus V1 times R3 over R1, which is 3 over 1, so 3 times this. All this gives an equivalent of 2.66. And if you do the calculations, you'll see that we have minus 3 times V1. So V1 in this case is measured here using the MI9. So this is the blue curve. MI10 is the yellow curve. So minus 3 times 7 here plus 2 times 14 gives you the 16 volts there. Last one just to show is the integrator one. So just look here. We have an integrator op-amp circuit, so including a capacitor. Again, you have the values of these that you can change. And in this case, just to show you the result of that, grab the plotter again. You can see here, maybe I'll run this one for a little bit longer. It didn't run for very long. You can see we're integrating a constant value here, so we're I guess it's negative, so it's decreasing, and then when it goes to negative, it's increasing. So you can see as the signal is constant, we get a constant slope in our integrator. Next improvement that we've made in this version is we've improved the calculation of the true RMS and frequency. So just to show you here a quick example, here we have, sorry, this is the previous one. So if we look here, we have now our plotters. So I just plotted this here. We now have the RMS is calculated here. So in this case, we have a 400 hertz signal that we're measuring using the measuring instruments here. And it's measuring the average voltage and the RMS voltage here. So if we just go back to the PowerPoint. So this is the example here. So based on the theory, the RMS value in this case, so with this 50% square wave, should be 7.07, given that the amplitude is 10 here. The average is 5, and the frequency is 400. So these are calculated correctly. In the past, just using the old RMS model, this didn't exactly give the right values. This example here then is a 3-phase inverter at 50 hertz. So you can see again, the theoretical value here is 19.55. The TRMS is 19.6, and previously the value was way off. Just a small thing to note with this, so there's the slight variance between the theoretical value and the measured value. This can vary depending on your simulation pace. If you have a high frequency signal and your simulation pace is not high enough, you can get bigger errors, but the faster your simulation pace, the closer these two values will be. Here's an example of a bridge rectifier. So theoretical VRMS is 230. We're measuring at 229. The average is 207. Here we're getting 206. So previously the values were quite a bit different. And here we have a 500 hertz asymmetric trapezoid signal. And again, we're getting the correct values here. So the next new addition to this version is the Aeronautics Library. So this is a library of components intended for use in the aeronautics industry. So these are various symbols that conform to the standards of that technology here. So a few different examples here of circuits that you can create using the new Aeronautics Library. And these components are available. So they're not in, if we look at the main library here, they're not in this library here. What you need to do is to go to the orange library icon here, click on Open Library, and open up the General Electrical Aeronautics. And then with that, you can take components from here. So the library structure is similar to the generic library here. And you can choose various different components there. So various switches and so on that will match the aeronautics standards. So there's a large collection of components that are available in there. Just as a reminder as well, so we have previously created a library of HMI components with various buttons and so on that can be used for creating this type of a control interface. So this, if we look at our catalog manager here, we have a HMI catalog which is available. This contains these types of components that you can just drag and drop similarly to how you do from the library here. So this is an older catalog, but just in conjunction with the aeronautics, it becomes useful, a bit more useful than previously. The last thing then we're going to look at is the component frames. So this is a new addition again in this version. So what that is it was sort of inspired by the aeronautics, but what it is it's a way of easily adding frames onto components. So if we just go back to our generic library here, just take a component here. On these components, I can just create a frame automatically around this around the component itself. So if I go to the Edit tab here, I can just click on Frame here, and what that will do, so if I just click away so you can see it, that adds this box directly around the component. And you can add, or you can modify that frame. So if I right click on the component that has the frame, I can go to Edit Frame, and here then I can draw it, change the size of it. So not just on the sides with no port, but even the sides with the port, I can sort of make it a bit larger if I wanted to. I can also change the line type, the line thickness. Sorry, I've actually clicked out there, sorry. So I have to go back in, edit frame again. The line thickness and the line color and so on. And then this, maybe that's a bit too thick. This then gets saved with the component. So now if I move the component around, this will get saved with it, or if I create a copy, it also gets saved. This is, so here I'm showing it for electrotechnical. It also works for hydraulics. So if we just take a hydraulic component, let's just grab a cylinder here, we can do exactly the same thing. So here again, we're in the Edit tab for the hydraulics. We can add a frame, and we can do all of the same things here. So we can edit the frame as well here. The standards here for this, so when you can see when I create the frame, it aligns with the ports and it leaves a certain spacing around the outside. This is defined in the project properties. So this is defined in the project properties. In the drawing tools, we have here a section for component frame. So this is the line color, line style, fill pattern, and the spacing here that I mentioned. So the spacing around the frame, there's a half a grid spacing, which is what we see here. If we just turn on the grid, we'll see it. So we have a half a grid around the component, and then on the side with the connector, it aligns perfectly with. So you can set this up to be whatever default setting you want. Let's just change it here to red. Oh, that'll do, it's close enough. And if we add in, well, this one is already changed, but if we add in a frame on a new component, you can see it automatically changes. So it takes the new changes. So that's it for the new features. Next we have a Q&A session, so we can pass you back. Thank you very much.
Great, thank you so much, Shane. Just friendly reminder, if you have any questions that you want to be able to ask, you can use the GoToWebinar chat box here. So we'll be taking some questions and going through some of those. Okay, so let's take a look at the questions available. Can we create our own 3D connectors?
Yeah, you can do. So the only thing is, like I said in the presentation, is you just need to make sure that you have the 3D file. So normally that would be provided by the manufacturer. I want to just show my screen because we do have the help file. The help in Automation Studio it does describe how to do that. So I just want to show the screen again. Just to show you where you can get access to that. So if we go to support, multi-line electrotechnical, let me see what it was. So here in the builder 3D tab, so in the connector builder, we have help that gives description on how to create a connector. So if we look at here, if you go through here, you can see information on, in this help, it gives a description on how to create from scratch your own help. We didn't go through it in the demo here because it's just as an overview, just to present the idea, but the information that you need is all available there in the help.
Good. We have another question. Will there be a catalog of connectors?
Yeah, so that is the plan. So we just have the connector builder. It's just available in this version. So we're working on building a new catalog for connectors. So we're going to start off with the Automation Studio Electrical catalog, which will add in Deutsch connectors that have been mostly requested by customers. But as depending on the requests that we get, we will prioritize different catalogs.
Good. Let's see. Can we use the installation colors from the cables on the schematic?
You can actually. Yeah, I think I skipped over that bit while I was doing a demonstration. But here, yeah, so there's different options in the project properties here for the display. One of the options is to show, rather than just having a generic coloring for the highlights, you can have check this box here, which will inherit the installation from the definition of the spool, for example. So here in this in this case, we've defined a wire spool with one of the cables has the wire has a coloring of insulation, yellow and green. So when that wire is displayed on the schematic, then it will show it as yellow and green like this.
Very good. Let's see. Do you have any VFD components available in Automation Studio?
Yeah, we do have them in the catalogs. So in the Electrotechnical Automation Studio Electrotechnical catalog. So they're not in the library directly, but let's just open the catalog here. We're just going to grab it. It's on the other screen here. So Automation Studio Electrical. electrical. So variable frequency drives here, we have a selection of different VFDs that are available here in this catalog here. So you need access to the manufacturer's catalogs to be able to get this, but once you have that, you can use any of the VFDs that are here in this library, in this catalog.
Very good. Do you take in consideration resistivity in wires and cables?
Yes, we do. So you can see here with the wire, the cable and spool builder here. So when you define your cables, you have the cross-section areas and stuff of the different wires. Based on that, the resistivity is taken into account. For certain wires, like we saw in the demo as well there, that if you want to neglect, so you can set certain wires as perfect wires, and for those we don't. But basically using the spool builders here, you can create the wires and the resistance is taken into account.
Good. Okay, it says you have 3D connectors. Will you make available 3D harness diagrams?
Yeah, so we're working on the development of the 3D harness diagram. So the connectors was the first step towards that. Like a lot of these projects are fairly big, so it takes a few iterations to get there. But yeah, in an upcoming version, we will have 3D harness diagrams that will use the 3D connectors.
Okay. Let's see. Will we be able to have the power balance on electrical machines?
Again, yeah, that's a plan for a future version. So it's something that we're working on to be able to add. So the next major release probably will be version 9. We should have the power balance on electrical machines.
Okay. Is that all the questions? Let's see the chat. Will we be able to have temperature on the electrical machine in simulation?
So not currently, we don't have that, but that again is another development that we're planning for a future version. So yeah, the next major version, we should have that added in.
Okay, great. I think that covers all of the questions that are in the chat currently. I don't see any other questions. Okay, well, thank you all so much for attending this webinar. Again, the video will be available shortly, so anybody who registered to the webinar will give access. If you require a link or other information, please feel free to reach out to us anytime. We'll be happy to assist. And again, these webinar videos will eventually be posted on our website in the webinars section for past webinars. So thank you again for joining us. Please be sure to attend the next webinar that we'll be covering. Until next time, bye-bye for now.
Bye-bye.